Welcome back. This is Math 111, 8.1, page 11 notes. Not all the time is our data normally distributed. So we have the central limit theorem. It considers the population with any shape of distribution. The average is still the same. This new standard deviation, still the same. But if the data is not normally distributed, what we're going to do is pretend that it is. The only way that we can pretend that it is if there's 30 or more data values in there. 30 more sets of samples. So according to atmdepot.com, the average ATM withdrawal is $60, standard deviation is 35. Do you think the variable ATM withdrawal is normally distributed or not? What shape would you expect? Can you make a withdrawal of 0? No. That would be a little less than 2 standard deviations away. Can you make a withdrawal of $120? Yes. That would be a little less than 2 standard deviations. How about $500? Some ATMs probably have a limit for maximum withdrawals set up per person, but you can make withdrawals that are 3 and 4 and 5 standard deviations up above. So what we're going to say is I would expect the distribution to be skewed right. In other words, it would have a very long tail on this side. Here's our 0 marker, here's our average. You can't take out less than 0. I guess that would be a deposit. Part B, if a random sample of just 10 ATM withdrawals is obtained, find if possible the probability that the sample mean would be between here and here. Again, they don't tell us up front that it's normally distributed. That is the key. So, can we assume that it's normally distributed? No. 10's not enough. We need 30 or more. So, this one cannot be determined. If a random sample of 50 ATM withdrawals is obtained, is 50 enough? Since 50 is greater than or equal to 30, we can pretend that this is normally distributed, or at least close to normally distributed. So now we're going to find the probability between 70 and 75. Here's our picture. Again, it's skewed right. Here's our average, right here at 60. Our current standard deviation is 35. Our new standard deviation of the sampling is 35 divided by the square root of 50. We grab our calculators. We can only do this again because the sampling was bigger than 50, or bigger than 30. Let's try this. 50 divided, turn it on. 35 divided by the square root of 50. Change it to a decimal. 4.9497. Now we want it to be between 70 and 75. So we want the normal CDF. Go into your distribution, normal CDF. The average, was it 60? The new standard deviation, or sigma, 4.9497. The boundaries. So we want pictorially this zone right here between 70 and 75. So the lower bound is going to be 70 and the upper bound is going to be the 75. I know in our actual notes, it shows the same exact problem, but they use a TI-84 calculator, so the parameters are, you have to memorize which order they go in. This one's nice because it just prompts you for all four parameters. That's 2%, 0.02.